Hey guys, and welcome back to another video. Today, we're going to be learning how to find the greatest common factor and least common multiple using prime factorization. For those of you who don't know, the least common multiple of two numbers is the lowest value that the two numbers are a factor of. The greatest common factor is the greatest number that is a factor of the two numbers. For example, the greatest common factor, or GCF, of 9 and 33 is 3, because both numbers have a factor of 3. But those are easy numbers. What if we try to find the GCF of large numbers like 64 and 144? Finding the GCF of these two numbers are going to be hard by itself. You could list the factors of each number and then find the common factor, but that would take a really long time. Instead, we can use prime factorization. So what is prime factorization? Let's take the number 24. First, we have to find different factors of 24. For example, 6 and 4. So now we have the different factors, but in prime factorization, you have to factorize it to a prime number, which means you have to factorize these two factors. 6 is made of 2 times 3, and 4 is made by 2 times 2. Now, all of these numbers are prime, which means we cannot factorize any further. Now let's do the same thing to 36. 36 is the same as 6 times 6. Both of these 6's are made by multiplying 3 and 2, so the prime factors are 3 and 2. Now let's make a Venn diagram. The first circle is the factors of 24, the second circle is the factors of 36, and the intersection area is the common factors between both of the numbers. Let's look at the common factors. We can see that both numbers have the factors 2, 2, and 3. In 24, the remaining factor is 2, and in 36, the remaining factor is 3. The factors that we circled will go in the common factor part of the Venn diagram. The remaining 2 and 24 will go to the factors of 24, and the remaining 3 and 36 will go to the factors of 36. To find the GCF, simply multiply all of the values inside the common factor area. 2 times 2 times 3 is 12. This means that 12 is the greatest common factor of 36 and 24. By using this method, once we lay out the prime factors on the Venn diagram, not only can we find the greatest common factor, but we can also find the least common multiple. How so? Well, all you have to do is multiply all of the numbers inside of the Venn diagram. 2 times the product of the middle numbers, which is 12, times 3 is 72. This means that the least common multiple of 24 and 36 is 72. Now that you know how to find the GCF and LCM of two numbers, let's try to solve a word problem. Jack goes to the park every 6 days. Jill goes to the park every 8 days. How many days does it take until Jack and Jill arrive at the park on the same day? How do we solve this problem? First, we have to understand whether we're supposed to find the greatest common factor or the least common multiple. Since Jack and Jill come to the park on different days, we have to find out the least common multiple between the number of days in between their visits. This means that we have to find the least common multiple of 6 and 8. To do this, let's use the method we used earlier. First, we have to use prime factorization to factorize these two numbers. 6 is made by multiplying 2 and 3. 8 is made by multiplying 2 and 4. 4 is made by multiplying 2 and 2. Both 6 and 8 have a common factor of 2 and nothing else. This means that the number in the middle of the Venn diagram is 2. The remaining factor of 6 is 3, and the remaining factors of 8 are 2 and 2. To find the least common multiple, we have to multiply all of the numbers in the Venn diagram. 3 times 2 times 2 times 2 is 6 times 4, which is 24, meaning that the least common multiple is 24. So, Jack and Jill meet in the park every 24 days. This time, you're going to solve a word problem on your own. Let's say you have 42 dimes and 98 pennies, and you want to put them in a stack so that every stack has the exact same layout. For example, if one stack has 3 pennies and 4 dimes, that means that all of the other stacks have to have 3 pennies and 4 dimes. What is the greatest number of stacks you can make? Go ahead and pause the video to try to solve the problem. Okay, now let's go over it. The problem says we have to find the greatest number of stacks you can make. This means we have to find the greatest common factor of both the numbers. Let's start out with the factor trees. 42 is made by multiplying 7 and 6 is made by multiplying 2 and 3. 98 is made by multiplying 2 and 49. 49 is made by multiplying 7 and 7. Now let's make the Venn diagram. Both of the numbers have a common factor of 2 and 7, which means that 2 and 7 will be in the middle, 3 will be on the 42 side, and 7 will be on the 98 side. Multiply all of the numbers in the middle, and you'll get 14. This means that the greatest number of stacks you can make is 14. And to go further, each stack has 3 dimes and 7 pennies. But anyways, that's it for today. Thank you for watching. Hopefully you learned something new, and I'll see you in the next video.